Okay. Back for another volume of independent front suspension design here on JEHC, Jason Elvis Herdcast. The most original name for a podcast thing ever. But, the original one I wanted was already taken, and that guy turned out to be a dipshit. So here we are. And tonight, I'm going to start with a few bits. A few questions that we had was race shocks versus non-race shocks, bypass tube layout, lead time issues, the business opportunity with that, scrub a compression movement, camber curve, Berkey steering, etc. So then I'm going to dive into lower arm fabrication design and some upper arm fabrication design and see how far we can get this evening. And we'll just keep pushing through, this primary outline, etc. Those of you who've been following this stuff, you know who I am. If you don't, trust me, it's not going to change your life for the better. But I own Tech Consulting, DIY Off-Road, and basically just doing this large-ish outline of independent front suspension design stuff. And to answer some of the questions, yes, I'm going to put a page up on DIY Off-Road that'll list out the different volumes, and I will put these outlines in PDF format for each volume so that you guys can follow along. Someone asked about if I was going to note it minute by minute. I might do that. I might not. It just depends on how much time I feel like investing into it at the moment, because I understand some of these podcasts are really long, but in general, there's just a lot of stuff to talk about, etc. So don't listen if it becomes too much, I guess. I don't know. We're just letting it ride. So for this evening, let's start off with the conversation of race shocks versus non-race shocks. And a lot of you guys will know or remember that when you're ordering stuff from King, etc., they have pre-runner series and race series. That's not necessarily what I am referring to in this specific avenue. And the reason why is because there's a lot of conflation between these other companies that are basically showing up trying to pretend that they make race shocks when we all know that they don't. The reality here is if you're building a serious pre-runner or a race truck, you're going to run King or Fox. They are winning pretty much every single race. And by pretty much, I mean almost all of desert racing. And when it comes to short course racing, you will find some Bilstein and some other bits here or there. But for the most part, desert racing is pretty much consumed by Fox or King. More recently, and I haven't taken, this is a very observational comment, but it seems like Fox has been doing better than King in regards to winning the big truck race stuff lately. Trophy Truck 6100, etc. But that doesn't mean that I'm trying to discredit King in any way, shape, or form. I definitely own several sets of King shocks, etc. But the point being is there is a clear difference between serious race shocks or shocks that would be on serious pre-runners versus the more normal stuff. And I don't say that to be some sort of bullshit arrogance that if you don't have King or Fox, fuck you, bro, you're a loser. That's definitely not the case. I am by no means a wealthy guy that's fucking racing trophy truck or anything along those lines. But I do have to uphold a very specific level of, referral, so to speak, when it comes to clients asking what they should be running in certain applications. And when it comes to competitive race trucks or big luxury pre-runners, etc., the bottom line is it's Fox or King, and no respectable individual will be running anything else. That's just how it is. Until that game can or will be changed, I will change that opinion. But currently speaking, if you're not suggesting those to the big truck clients, well, the argument could be made that that's just not great. It could be in some situations unethical, and I will get to that in a second. But the point being is there's a lot of individuals that are conflating these other shock manufacturers, so to speak, into what is considered race shocks, and it's just not the case. The proof is in the pudding. Look at the results. Until they can start showcasing and showing up and having those results, they really should not be calling themselves race shocks, period. Just because you throw your shocks on some cheese dick, random ass level truck that, can show up and start a race, that does not mean, you're a race shock. You need to be winning races at these higher end levels to legitimately be selling shocks to these higher end level trucks with that claim that you're a race shock. And now the reason I say that is because there's a clear differentiation too between what I'm referring to with competitive race trucks and like luxury pre-runners. And I have some videos on that too to help describe that. But the point being is not every build is in that direction. So the vast majority of the market can fall into more run-of-the-mill based shocks, or what I would consider like non-race shocks. And that's totally fine. And fine for the vast majority of guys, including myself. But when I'm talking with a client that's starting, and here's a perfect example. Last week, we just started another 6100 for a client. And that was one of the conversations. What shock package? And it's very simple. You pick Fox or King, and that's it. And we go from there. We don't even entertain other brands. And like I'm saying, until those other brands can start showing themselves to be in that realm, it's just not, I'm not going to be suggesting that. That's just the reality. Now, with that said, I do got to bring up some story time, because I do have to go through some fuckery that I have witnessed too. Because there's a lot of guys, companies, whatever you want to call it, that make some claims, things along those lines that are just not rad. And so like I'm saying, I stick to race shock stuff, which would pertain to Fox or King. And I'll get to this specific image in a minute. But what I'm referring to is there's these newer companies that are basically like machine shops that more or less just knock off shocks and put them up for sale. And they're capitalizing on the fact that they can machine stuff faster than the lead time issue with Fox and King. And I'll get to the lead time issue in a minute. Now, with that said, I know there are quite a few other guys that have been happy with like ADS on some of the bigger truck stuff, because they do run big truck stuff, and same with Swayaway. Now, those would be like the next tier down from like a Fox or a King if I was giving like a tiered sort of recommendation to a client in the big truck stuff. Now, that is definitely a little bit more odd per se. Now, when you step out of the big truck stuff or step down to more run-of-the-mill mass market pre-runner stuff, you're going to have a larger variety of shocks that are available. And I'm forgetting some names, but like obviously Swayaway, ADS, I'm doing bad at this, but there's another company that we've done, and some of the rock racing guys use. Their black tops, starts with an R. Anyways, the point of Bilstein is another one. The point being is, when you're stepping outside of like the 4.4 inch, 4-inch bypasses, 3-inch plus coilovers, big truck stuff, you can easily run these other manufacturers' components and have no problem. There is a big difference between a shock that's a caliber of a race shock and what I'm defining a race shock versus a non-race shock. And that is, anybody can just start machining shocks and putting them together, and they're going to work for the vast majority of the market. But when you start getting into these big trucks that are driven appropriately, like a luxury pre-runner and race truck stuff, all the machine tolerances, the fit and finish, all of that is going to show itself very quickly, and the performance aspect of the shock is going to show itself very quickly. What I'm getting at is, it's not very difficult to basically rip off some other shock design to some degree, machine your own shit, put it together, and it's going to work for the majority of guys. Now, on the competitive race aspect, no, it's not. And the reason for that is you're going to start seeing stuff not work right, leak like a fucking sieve, build pressure way too fucking fast, cavitate almost fucking instantly, because now you're stepping into the realm of these big trucks, big shocks are being utilized in a fashion significantly harder for longer periods of time than the vast majority of the market. That's why I'm saying the vast majority can get away with stuff that is not deemed race shocks by like myself or other individuals that are in that side of the market, so to speak. One of the companies I'm referring to, and we get asked, and this is a little bit of story time, a lot of guys like a year ago were inquiring about carbon shocks from DIYoffroad.com. I have never used carbon shocks at all, whatever. So I was like, well, before I start recommending them, I'll just buy some for one of my personal projects. I'm building a crew cab, 4-wheel drive, all-wheel drive Chevy Colorado pre-runner with a bunch of stuff from DIY, links, things like that. It's just got 10-inch 2.5 coilovers up front, 18-inch 2.5-inch coilovers in the rear. I am going to do some bypasses. I haven't purchased those yet. So I reached out to the guy that owns Carbon, and I was a little hesitant, but, you know, like I said, before I'm going to start suggesting anything to like a bunch of guys off of DIY, I was going to buy them and try, you know, get them in my hands and see them firsthand before just willy-nilly being like, yeah, go ahead and buy all that stuff. I totally think they're fine. Because I've seen shock companies come and go multiple times over where it's just fucking dipshits with a machine shop that all of a sudden think they're some sort of fucking shock guru. Not the first, won't be the last. So with that said, I contact him and tell him, and this is where I'm going with this picture here, and the next one, this picture too, is I contact him and tell him like, hey, do you have design models so I can put it in our assembly and start designing everything off your shocks? And he's like, we can't give anything out because everything we do is proprietary. Red flag number one. And so I'm thinking to myself, oh, this is going to get fucking good. This is going to get real fucking good. And so for those who don't understand how the industry works on the design side and things like that, there are basically what are dummy models that are all the manufacturers hand out. What you see on the screen here are dummy models from Fox. On the left is the actual like full dummy model. On the right side, what I have done is hidden the main body. So when we're designing stuff in the computer, etc., what we need is external constraints to dictate a spatial constraint, so to speak, relative to the chassis, relative to other bits, the arms, things like that. All the shock manufacturers have small variances that can make things either a complete pain in the dick for us designers, if we're real particular about how the mounts and plate work are structured, that we need to have realistic measurements to go off of. So King and Fox, they provide guys like myself what are basically like builder or dummy design models. And so it's enough for us to get going. But as you can see, when you hide the shock body itself, there's nothing proprietary in there. No pistons, none of the proprietary stuff, in essence, that you could use to, in theory, steal the quote-unquote proprietary information from said Fox shock is in that model. So there's no way I could even make a shock, so to speak, from the models they give me. And this is a common industry practice amongst a ton of stuff, whether it's Jason at TubeWorks sending me things, David ID, I mean, you fucking name it, the Gearbox guys, all the different companies that, in essence, I have to acquire a model or an assembly to then put that into my assembly to design around. And so I kind of explained this to the guy at Carbon, and it just like basically just pissed him off. Like, how fucking dare I? And I'm just like, bro, like, this is normal. Like, it helps us tremendously to make sure that what we're doing fits, especially because like there's lead times with shocks. And I'll get to why that's an issue in general. But so with that said, I'm like, red fucking flag city right here, that you can't even send me a dummy model because quote unquote everything is proprietary. So right there, I'm like, oh man, this dude's full of shit for sure. So right off the bat, I'm like thinking they don't fucking have models. So this is a high probability of a situation where they just took like a Fox shock and fucking had their machine guy basically make the machine files to make it. So the lacking of the fundamental understanding of how a shock would work, operate, etc. is not fucking there. I mean, I unless they can fucking prove otherwise, I would be very surprised. And so I'm like, so you're so fucking proprietary. that your external constraints are fucking proprietary. So apparently they're so proprietary, so much more proprietary than race shocks like King and Fox, that they can't even send out external constraint dummy models. So again, just mega fucking red flag. And what concerns me is they're selling fucking big boy bypasses now and shit, and they seriously lack the fundamentals or the ability to appropriately put that shock together and test it. These shock packages for these trucks are well above $20,000. Some infringe above $30,000. So you're betting a large chunk of your disposable income on basically a fucking dream. Now, the individuals that are putting together these Fox shocks, and like, so here's an example, like here's the bypass dummy model from Fox. This is a trophy truck rear shock. This is actually what I have in the computer from the engineers at Fox. These are the dummy shocks. So when I hide the main cylinder, you can see here, there's no proprietary information in this. So both King, Fox, etc., this is how it's done so that guys like me can do things appropriately. So you can see where I'm going with this. It's a very weird situation to have such a red flag pop up so fucking early in that thing. And then, you know, the only reason that they're having sales is because of the lead times of Fox and King. Right now, if I'm putting in an order for 4.0 bypasses, etc., with a client, 3.0 colors, it's going to be like 12 months from Fox, realistically. And King is going to be in that range too, depending on who you talk to. I know some guys will tell you it's a few months, etc. I highly doubt that. I just waited like 10 and a half months for a set of off-the-shelf coilovers from King because I did not buy anything from Carbon after mega fucking red flag city from those guys. Now, with that said, there's a good probability that Carbon shocks will be fine for a chunk of the industry, but let's be crystal clear. They're nowhere near fucking close to race shocks. And it's incredibly unethical for them to portray themselves as even remotely close or anything along those lines. And it's even more unethical for someone like me to even suggest anyone building big truck stuff or race truck stuff to go that direction simply because they're trying to obtain something faster than what the current lead times are for Fox and King. So, with that said, if I'm passing off a design or something and someone's like, oh, I want to run these shocks, and it goes south, which, like I'm saying with the Carbon stuff, it would be very odd if it doesn't, because to get a big shock like that to work on a big truck appropriately, you got a lot of heat accumulation, pressure accumulation. The machine tolerances are going to be real fucking obvious if they're fucked up, even remotely off at all, especially the assembly, all this stuff, and they need to be dialed. That's why Fox and King have done such a... I mean, this has taken decades for them to perfect this so that someone can just come out of the gate and magically have a shock that's as equivalent. I'm sorry, but it just ain't fucking true. Not even close. So I just felt like that was some good story time on something that is very weird and arguably unethical. But I've seen a lot of unethical stuff. This just reminds me, like, let me see if I can find it real quick. Let's pull up, because unethical stuff happens all the time. Let's see. There we go. Reese Millen. This is a classic. I saw this like a year ago, and I don't know if he has fixed it or changed it. I'm going to vehicle builds. Oh, fuck, he hasn't. Fuck yes. Ethics be damned. So that's not a Reese Millen truck. This is him trying to sell a Jackal all-wheel drive truck. That's a fucking Alumacraft 6100 truck. That's not even an all-wheel drive truck. That is a spec truck built by John and Brian at Alumacraft. Brian is a great fabricator. So watch. We'll go to Alumacraft. I know this is a side tangent from this discussion, but like this is just fucking hilarious. Let's see. History, contact, news, photos, links. Trophy Truck 6100. This is that truck. So Reese on his website has fucking Alumacraft trying to sell his fucking Jackal 4-wheel drive truck. I'm pretty sure Igor is the one that does his design work. You would think that, like, at a minimum, he could fucking have Igor just draw something real quick in the computer and get, like, a decent render going instead of using a fucking competitor's 2-wheel drive 6100 truck to fucking sell their 4-wheel drive new truck. But yeah, so like I said, this shit happens all the time. Welcome to fucking off-road, man. It is what it is. You just got to take it with a grain of salt. But yeah, so with that said, let's push forward. So no, I am not a fan of the carbon shocks. Definitely do not recommend them. But whatever, to each their own. So let's I want to show you bypass layout stuff because I had somebody ask me about how we're doing that. So in the computer in CAD, we're for the most part like placing them, and then so these are off-the-shelf Foxes. So like this is an actual part number from Fox. If this doesn't work and I need to manipulate it, I'll move those tubes around, orientate them how I want relative to the chassis or what we're fitting, which sometimes we don't even have to do. Like the off-the-shelf stuff works for a lot of these 4-link based like trucks, 6100 trophy trucks, luxury pre-owners. But if I do need to move that, what I can do is move those around, send that step file or CAD file over to the guys at Fox, and then they can take that and build the shock from there. I can do the same with King as well, but let me show you another way of doing it as too. That's kind of a little bit more old school that we've had to do in the past. So here's a rear bypass. This was for a luxury pre-runner that had like where the shocks are pseudo in the cab, so it's a little funky with layout and placement. So that's why this is done this way. And what you're seeing here is these are the tube locations for the bypasses, and obviously here's our remote reservoir hose lead. And on this setup, we've got 15, 17, 5, FFF. So what this means is this location here has clearance up to 15 inches from the bottom of the can, so to speak. This has clearance up to 17.5 inches. This has full clearance. So those 3 spots are fully clear. The reasons these don't is because there's actually some tube structure that's kind of in that way that would make this a real nightmare to get to those tuning ports, so to speak. So we give it a few inches of clearance to at least, hopefully make the shock tuner not fucking livid with the chassis designer. And here's the front bypass. So 14.25 inches from the bottom of the can is the height, max height for that one. And then obviously these are full length availability. So again, just different way of us telling the shock manufacturer, hey, this is where I want the layout relative to this is a 4.4 inch bypass, the placement for my chassis, etc. If we're not doing it in CAD, I mean, most of the time these days we can do it in CAD. The bypass layout part, however, though, is a little bit more old school, and I'm trying to remember what shock, because that was actually going to a non-King or Fox shock guy, and now it's escaping me which shocks manufacturer that specific print was going to. Either way, it doesn't matter. We had a question on how I like to do that, and like I'm saying, if it's not in the computer, we make a simple PDF from that with a measurement that's from the bottom of the can up for a clearance, and then obviously the circles are the reference of the clocking. I feel like it's fairly self-explanatory. Most guys should be able to figure that out. If not, maybe they shouldn't be building fucking shocks. How about that for starters? And that leads us to, so the lead time issue, like with King and Fox, and like it's very difficult to get around. So, like this brand new 6100, it is I can't really disclose who it's for yet. I'm sure we will at some point in the next few months, or we'll post on tech or some bullshit in the next few weeks, etc. I don't know if it's a father-son team. I don't know if the son is okay with that yet. We'll figure it out. But long story short, we had to deal with the shock issue, and so Fox was a little bit gnarly on that. Now he did get lucky and KDM Keith Marigold had a full fucking 6100 set of shocks ready to shred, which are 3.0, so 14-inch stroke, 3.0 front coilovers, 4-inch bypasses. So on the 6100s, we have been running 4-inch bypasses, not the 4.5s, with a 2.5-inch by 2.5-inch front bump. Then for the rear, it's an 18-inch stroke, 4.5 bypass, and a 16-inch stroke, 3.0 coilover, with the bolt-in 4-inch stroke, 2.5-inch diameter bump stop. So fairly standard 6100 package. Now, I don't know what the fuck the deal is or who fucked out on that specific package, but long story short, right place, right time. The KDM guys, Keith Marigold, had this set for our client. Boom, souped it up. So his effective lead time was like 4 days. Now, that's not going to fucking happen if you call King or Fox for obvious reasons. So you have to be able to keep that into account when you're dealing with this. And even like with my bro hookup and knowing people, I still pay for my shocks. I don't get anything for free. And I still wait. My last set of coilovers from King were over 10 months. And then the set before that was actually a deal of right place, right time. I bought a full set of internal bypasses for one of my UTVs. And that was Baldwin Motorsports filled out of that order. And I was just right fucking place, right time. And Brett was like, you'll pay for them today? Fuck yeah, I will. Here you go. And full pop on that. But again, shocks are kind of a pain in the dick. So it's something you got to figure out ahead of time and get all your ducks in a row as soon as you can with your chassis guy. Because you could be waiting on shocks longer than the other bullshit. The other argument could be like maybe like fucking radiators and cooling systems could be just as long. But yeah, it's been a little difficult for the shock side of the equation to some degree. And which is even funnier because like companies like Carbon, they are basically only making money because their lead time is less and they still have a lead time. So it's not like you can get shocks right away from even them. It is by default a little bit of a wait no matter who you're ordering shocks from today. I just don't know the specifics with ADS's lead time, Bilstein's lead time, Rycor shocks lead time, or Swayaway shocks lead time. But I would assume they're all just as fucked as Fox and King. So yeah, some little insight into that. Well, I had another. Let's see. I've got a few other questions. Oh, yeah. So V5 start. There we go. We'll go through that in a sec. Let's do this one. So I had someone ask me about this. It was something I had mentioned, and I think the podcast volume 2, and it was, I mentioned it really quickly, but what it has to do with is, basically, mitigating some of the movement of the contact patch relative to your scrub when it comes to full compression in a straight line with the trucks that have a lot of camber change. Typically, some of the beam trucks, race truck stuff ends up with a lot more camber change. So sometimes we'll scoot the scrub out a little bit because what happens in these off-road trucks in a straight line only, you'll see that yellow contact patch, so to speak, and that center point of the contact patch start to shift inboard. So it will start to reduce your scrub radius a decent chunk sometimes, depending on some of the characteristics. So in an effort to avoid that from getting too low or going into the negative side of the equation, so to speak, you would open up your scrub radius initially with design. Like I said, I've only seen this a few guys that were concerned about this in a few situations where there's a ton of camber change at compression, and very few guys even understand or care about this, so I don't even know if it's even worth talking about. It's a moot point, but what I'm getting at is in these off-road trucks, that sort of contact patch likes to fucking wiggle inboard when you start to get a ton of a camber change in a straight line. Now, once you start turning and the vehicle starts to set, so to speak, like this, then the tire actually, even though there's a ton of camber change, starts to sit a little bit, more straight up or like the inverse. But the point being is at that point, you're back to it looking more like on the right, even though the truck may be, pretty cattywampus going through something. So, yeah, just wanted to mention that because I had some questions on that. And so, again, I don't think it's that relevant. I don't think a lot of people focus on it, nor is it a big deal to be concerned about to some degree. If you're in the sort of scrub radius numbers I was referring to before. So like, here's a perfect example. If you're building like a beam truck that you're running 4 or 5 degrees of camber at ride height and a ton of, camber at the compression side, 12, 13 range, because on some of the beam race truck stuff, we get up there pretty high. And you're running that scrub number down to like fucking quarter inch, half inch, that fucker can shift into negative territory at compression for sure. So again, like I'm saying, and like I had talked about during that volume, is I like to be closer to like 1.25, 1.5 on the scrub. And by default, you're mitigating this because even in its worst case scenario, you might be seeing like a half inch of scrub. It's not going to shove itself all the way over, so to speak. And this is something that's kind of unique to these off-road applications. Like, you're not really seeing this shit in a road race car. It just doesn't really happen. Also, when it comes to like road racing and things like that, like you're not as concerned about the stuff in a straight line, whereas in off-road, you're going through the rough stuff in full compression and lots of camber change in a straight line. Again, road racing and other aspects. It's just one of those things that like, it's very difficult to start applying the same principles and theories you see in road racing and other forms of motorsports to off-road. It doesn't fucking work the same. Some of the generics do, but for the most part, most of it just gets thrown right out the window and has no effect whatsoever. So there goes that question. Next, this did pop up when I was talking about the steering volume 3. And we had some questions on this. So this is for a Mud Racer chassis. These are for Jake Berkey's new independent front suspension Rock Racer Mud Racer chassis. I don't know if you've seen them. They're fucking wild. Let me just pull one up just so you can see what I'm referring to. It's these things. These guys. So I designed a new independent front suspension for his chassis. And that is the steering system that he wanted us to integrate. Let's go back to that picture. And so what this is, it's a slider basically on a fully hydraulic system. And it acts like a rack. So it's just linear movement back and forth in the chassis on these two machined bars that are like hydraulic cylinders that basically slide on Delrin in that aspect. And then on the interior side, it's this like a ram, that you have on the Rock Racer solid axle stuff. And this is what he wanted to run. This would be something that's a little bit more unique, and you have to keep in mind it is fully hydraulic steering, so not something that would be considered ideal for the desert racing type stuff. But these are like I was saying, these are like mud racing, rock buggy applications that are just totally fucking wild and different. Let's see, maybe we don't get copyrighted. But so different strokes for different folks. It's just a different way of doing stuff, And so it acts like a steering rack, so it's linear in fashion. So geometry-wise, I set it up basically the same as I would a normal steering rack from like Power Steering Solutions or Howe or stuff like that. The only difference here is it's fully hydraulic, and it's running on these two shafts, just back and forth. And I don't remember, but I want to say this was like 6.5 inches of throw range, right in that ballpark. So again, very similar to the steering rack stuff that you would be seeing from like PSS. But yeah, so that is just covering some questions and things I got for, the last few weeks. I just wanted to hammer on those real quick before we dive into some fabrication of lower arm stuff. So now we're going to start talking into fabrication aspects. So like the construction and building of the parts, not so much geometry aspects of said part. And so, so let's start with lower arm chassis pivots. Okay, so for obvious reasons, the lower arm mounts to the chassis and the upright. And there's differences in a lot of this stuff. So let's pull up we're going to focus right now. I'm just trying to review some pictures. Trying to remember everything that I have. Try to get a good sampling of everything. The one picture I was looking for is not really in here. But whatever. Here's a good one to start. So this is done by Derek Dump. Very famous thread on Race Desert. If you ever have a chance, just Google something new on Race Desert. And in fact, we can probably just pull that up. You can drool over this. Some time. It's a bunch of pages of fucking just some gnarliness, man. This is old now, so these trucks are no longer operating. I'm pretty sure. The new stuff they have was done by Craig Hall. This stuff was all done by Derek. And what I want to show you is they have this. I'm trying to find this one specific picture, so just bear with me for a second because I realize it's not in my section. But yeah, if you want to look at some intense fab work, fixturing, tooling, I mean, fuck, these guys, when they did this at the time, like, there really was only, like, SPD was, like, one of the only builders doing stuff to this caliber. SPD was the previous ID Designs. Ooh, there's the miter section. I was going to speak about that, too. How to properly do that. Come on, Derek. Where the fuck? There's this picture of the lower arms on a racks, and I just want you to see the spread. Because what I want to talk about right now is like spread of the lower arms on the chassis and some of those aspects, and what you can get away with and what you got to watch for with those spreads. This is getting a little drawn out because now I'm a little frustrated that I can't find the specific picture I'm looking for. There it is. Okay, cool. So yeah, so this is so what you can see here is this is a really widespread setup. Now, inversely to that, a lot of the stuff I've been like the stuff that's on DIY, a bunch of arms I have on there, etc. We have a narrower spread than that, and there's a reason for that. And the primary reason is we do have the same arms that run with bulkheads that have rake. And when you run rake in a bulkhead, that rear pivot of the lower arm, you don't want it to end up too far down in the chassis. And inversely, you don't want the front pivot upper arm to be too high in the chassis. So if you have a really wide spread lower arm, it starts to dig it a little far down, so to speak. And it can start to be a little bit of a headache with your extension, compression, and getting the geometry just right if you're running rake. If you're not running rake in the bulkhead, your bulkhead's flat, you can get away with a much wider spread lower arm because you're not running the risk of that height change in the chassis starting to be a dick with some of your geometry characteristics. So with that said, like this Herps arm is a good example of a pretty wide spread on the chassis, and these were like flat bulkheads. And there's nothing wrong with that. If you can fit it, there's definitely no problem with having wider spreads. Like I'm saying, I'm running, typically speaking, because a lot of like the arms on the DIY, etc., a lot of those bulkheads do run some rake. So we have a little bit narrower spread, only by a few inches. It's not like it's, 10-inch difference. We're talking like a 2-inch difference of spread. That little bit difference is just, it helps with that height change in the rake bulkheads. So spread in the chassis, obviously you have to pay attention to that. You don't want it to be too narrow. Like here's an all-wheel drive that's pretty wide, but you have to keep in mind we have a differential in here. So this pivot is in front of the differential. This one is behind the differential. Here's an ID one. You can see the spread on that too. There's that all-wheel drive one I did. This is a 7200 one. Again, really simple arm. That was a very lightweight 7200. These are the newer Herps arms. So these are the ones that I'm pretty sure Craig did on on the newer chassis. And again, you can see the spread on these is not horrendously wide. This is one of our T4 arms. Again, not horrendously wide. And these do run some rake. So I'm kind of pushing the limit on the width with the chassis spread on those. That's one of... this is an arm. I don't remember who I designed this for. Oh, this is the Izzy Fabrication chassis arm. And this is based off of our Stage 2 front bulkhead. That's right. Forgot about that. So he's running one of the DIY Stage 2 bulkheads. And then I drew new arms for him off that bulkhead. But yeah, so when it comes to the spread of the lower arm in the chassis, you definitely don't want to be like 12 inches. You want to be more than that. And you also just, if you're running a flat bulkhead, you could run it back to like 20 inches or change. You could be pretty wide. But if you're running rake in the bulkhead and you start getting too wide and you start pushing that rear pivot too far either down in the chassis or the front pivot ends up becoming too high in the chassis, thus fucking up some of your extension stuff, you just got to keep an eye out for that. So that's sort of that battle you have to play when it comes to the spread of the lower arm in the chassis. Now, Delrin bushings versus bearings. Okay, cool. So here's an ID arm, and I'm pretty sure this one is running Delrin. And I do know, there's still some guys that are running Delrin. Racer Engineering, I want to say, does run Delrin. Let me see. I think I have a Racer arm in here. Yep, there you go. That's a Racer arm. So that is a Delrin on that arm. This is an arm we did for a client. It's bulkhead that's on a big luxury pre-runner type of application. And they are running Delrin in that. So it's kind of hit or miss to some degree. Now, all of our Stage 1 type stuff runs Delrin simply because of cost incursion. It's a little bit cheaper to run Delrin because you can pop in new Delrin bushings fairly cheaply. Like, it's not difficult to machine those or not very expensive to machine the Delrin. The difference here is when you're running Delrin for the chassis pivot, you are, in essence, having that rotate on the Delrin sleeve. And so it's rotating on basically two bolts that are straight with the Delrin bushing, and there's no room for it to be cattywampus or off. They have to be perfectly parallel, and they got to be dialed in. Otherwise, the Delrin will start to bind through travel. Or it could just be binding as you install it. So that's why some of the guys steer away from Delrin, myself included, on a lot of the more bigger race truck, nicer stuff, like our Stage 2 and Stage 3 type stuff, a lot of race truck stuff I do. I actually run 1-inch spherical bearing cups, uniball bearing cups, for the lower arm pivots. And the reason I like using spherical bearings for the pivots is because even if the arm is slightly cattywampus, or the chassis mounts are slightly cattywampus from weld warpage, whatever you want to call it, from the computer to real life fuckery, it's still going to pivot on the center point of the bearing. So it gives you a little bit of that give so that it's very free flowing. So some of our race UTV guys have switched all of their arms over to running 3/4 inch bearing internal pivots on the chassis side as opposed to a bushing. Now, there's definitely guys that successfully run bushings. All I'm saying is that the bushings, although cheaper, can be a little bit more of a pain in the dick because you need to fucking be dead parallel on those guys for it to cycle cleanly and have no bind. So there's sort of the catch-22 to whether or not you're going to run a spherical bearing or you're going to run a Delrin bushing in that lower arm. These are spherical bearings with a big spacer. So there's another thing. I didn't even fucking have that in my my outline. I just realized. But this spherical bearing spacer has a really big head diameter to prevent it from wanting to dig into the plate work of the lower link mount. You want to avoid too small of a head diameter on the lower arm pivots because the lower arm, when it's taking shock load, it wants to basically shift in the chassis, so to speak. And unlike the rear link typically is taking a shock load of pulling it from the mount where it's it's not shifting, so to speak, side to side in the same fashion. So on the lower arm, what you typically see is if the head diameter of the spacer for the spherical bearing on the very rearward mount side, so like the furthest mount side in the chassis of the lower arm plate work for the lower arm mount, that's where you start to see that spacer really dig in. And it should be fairly fucking obvious. And if that starts to happen, what you need to do is hopefully catch it before it gets too bad, and either maybe put a new tab in or plate, or get a spacer for your spherical bearing end that has a really big head diameter. And what I'm referring to head diameter is that exterior part. So let's go to Cartech, and I can show you exactly what I'm referring to with the head diameter. Menu. No, let's go shop category. So there's just another little tidbit that is very important with the lower arms themselves. And so 5/8. So like I'm saying, 1 inch is fairly standard for like a lot of the arms I draw. So this does have a decent sized head diameter in this guy. So B is your head diameter. He is almost 1.5. So that's pretty fucking good. That is not bad for a head diameter on a lower arm. I want to say these are bigger. These are like 1.75 or 1.875 range, a little bit bigger. But the point being is, if the head diameter is too small on the pivot, this backside right here typically likes to start really digging in to the chassis and can start to fucking cause some problems. And then you'll end up with premature failure, etc. This is an arm we did for a trophy truck client. Brand new front end. They tore off the current front end and they were replacing it. Yeah, so here's that arm. And they actually have one of our stage 2 bulkheads. So that specific client has a stage 2 front end on a luxury pre-runner. He likes how that truck works so fucking well. It has one of our stage 2 Y-frames in it in his luxury pre-runner, that we took his race truck. They cut the entire front end on the race truck. I'm using a new version of a stage 2 bulkhead, but the same geometry, so that the same arms and everything can go onto the luxury pre-runner as well as spares for their new race truck. And so, yeah, and those are 1-inch spherical bearings on the chassis pivot. This is an all-wheel drive arm with 1-inch spherical bearings on the chassis pivot as well. I want to say this is using Delrin. This is one of David ID's lower arms. This is for a very lightweight 7200 truck that we did. These chassis pivots are 7/8 spherical bearings. So we were able to go a lot less weight on that. This is one of the Herbst arms. This is one of the T4 arms. Those are 1-inch spherical bearing pivots. This is the arm for Izzy. And again, 1-inch spherical bearing on that interior side. And I do like to use the cups that are taller. So the cups that those are, I'll show you right now the equivalency. I do have some of my own. A lot of guys machine their own cups these days too. Because sometimes places like Cartech, they don't have everything in stock all the time. And sometimes it might just be easier for guys to just make their own. So cups for 1-inch bore. Yeah, here we go. This one, 2.5-inch tall, 2.5 diameter. So this is a standard cup I would use for lower arms. I like that 2.5-inch tall chunk to have the pivot made out of that. So that would be what all of these arms I'm showing you utilize in. So these are all those big cup stuff. So yeah, so let's review real quick. So if you're using a spherical bearing like this, it's going to rotate on center point of the bearing. So if these are ever so slightly cattywampus, or the chassis is so slightly cattywampus, it's still going to pivot freely. Very fucking smooth because it's pivoting on center of the bearing. If the Delrin is not perfect, or the chassis and with the Delrin pivots are not perfect, you're going to get some inherent bind in the system. It could crack the Delrin prematurely. It could fail. It could fuck up. So those have to be done fucking dialed, you know? So you got to account for the weld warp and really watch it when you're doing the Delrin stuff. I have seen, okay, so all of these are what would be considered like horizontal bearings. So some of like the old Alpha cars, and you don't see it these days, but 10, 15 years ago, there were some cars built, race truck stuff, where the bearings were facing the other direction, where the bolt is vertical instead of horizontal, for the lower arm chassis pivot. And some guys do prefer that. I'm not a big fan of that for two reasons. One, I feel like the bearings wear out faster. And two, when you build those, you have that bolt head sticking down in like a section that you kind of don't want it. Like it could totally be torn off. Or you have to build the bulkhead like, bigger and thicker with that bottom section to protect the bolt head. So you lose some ground clearance there. So for the most part, all the trucks built these days, they're running these horizontal. They're not running like the vertical bearing bullshit that you see from before. But that doesn't mean that those vehicles that are running that is wrong, because some of them are some of the best fucking handling vehicles out there. It's just not a style that is common these days. Pretty much all of them are going to be bolts that are horizontal in this fashion. Like I don't even think I have any vertical bearing pictures in here. Yeah, these are all horizontal on the chassis side. Yeah, all horizontal on the chassis side. That's a Delrin bushing arm I drew. Yep. Spherical bearings. This is the lower arm for Ross King. Spherical bearings. This is one of our stage 2 arms. Delrin on these. These are just our stage 1 plasma table friendly stuff runs Delrin. I'm talking just the chassis pivots. This is a Tisco arm. TSCO. And I believe they are running spherical bearings. Delrin on, this is an all-wheel drive stage 1 front end that I did. So plasma table friendly stuff, we run the Delrin stuff. It's a little bit more on the budget friendly-esque avenue. T4 arms. So this is a little bit of optical illusion. Those are actual spherical bearings, but what you're seeing are Delrin wobble stoppers that are put in there. So if you're using a what do you call it? Like the wobble stopper-esque Delrin like this, you could do that. We have had guys do that. But like I'm saying, the preference would be to run the much larger head diameter spacer in place of something like this. But there are guys that run this and prefer this. So again, different strokes for different folks. This arm could run either or because it is just a one spherical bearing. So you could put a much larger diameter head spacer in there and it'd be totally fine. But yeah, so that is some of those applications. Oh, let's go bolt sizes. Pretty much all of these lower arms for any of the full-size big truck stuff is going to run a 3/4 inch bolt. I have seen guys run 5/8, but these days I design pretty much all of them to have a 3/4 inch bolt on the chassis side. Unless it's like some of the buggy stuff, the lighter weight buggy stuff, we'll run 5/8 for that chassis side bolt. But you're talking much lighter vehicles than a trophy truck or luxury pre-runner application, like fucking half the weight. You can get away with a 5/8 bolt on that chassis side. UTV applications, like I was saying, we have done guys with UTV stuff that run spherical bearings. One that I can disclose is Master Fab. Yes. I cannot spell for shit. Master Fabrication. Cool. So yeah, so like this guy's, they are running 3/4 inch spherical bearings on the chassis side, and they did do a video on how smooth it is. Because on the UTV stuff, it's pretty fucked. Like the stock cars just suck balls. There's no way around it. And we went to the spherical bearings. Oh, here you can see his lower arms in this. So he's running, 3/4 inch spherical bearings in the lower arms, and it's really smooth, really smooth. So we got rid of the Delrin and that stuff, but again, it costs more money to do that. So I think this is the post. Limiting binding get, WSSX-12. There you go. So this is exactly what I'm referring to. Look at the fucking head diameter on those spacers, boy. That's proper right there. And so ever since we started doing that, they alleviated a lot of issues with premature wear on the Delrin bushings, any of that bullshit, man. It's working really well on in these arms. They have a bunch of guys racing with this shit too. So again, different strokes, different folks, but this is a perfect example of utilizing bearings to pivot on center point for the chassis pivot as opposed to a Delrin bushing, which pivots on that bolt, so to speak. So now let's focus on the upright pivot stuff. These days, now we used to, on like the trophy truck stuff, we would use the big bearing stuff. And it was pretty common. And I'll show you exactly the difference in those. Cartech still sells them. Although, like, no one really, I don't really use them anymore. I use the COM24Ns. And I've had like discussions with several, so per example, so here's the trophy truck bearings, $450, $460, $70 for the 1.5 TT bearings. These are a bigger version 1.5 bearing than what would be the equivalent like COM24N bearing, which would be something like this, or sorry, 24T. There we go. That's what theirs is. So what I'm getting at is the step up to larger ones would be more rare these days as opposed to the norm. The norm would be the COM24Ns, 24Ts, because we're seeing the same sort of wear and issue with longevity on that bearing as opposed to the big trophy truck stuff. So it's kind of pointless to go to that. Now, we do have a few clients that are specific. They do want to run the big TT shit. But with that said, most of the guys, I'd say, are going back to the 24N, 24T stuff simply because of cost, and they're like basically getting the same life out of them. They're both equally as strong. They're 1.5. They both have just as much, more or less, have plenty of misalignment built into them to where like you're going to get the same amount of wheel travel for the most part. So you don't really have to worry about that. I even had this discussion with David ID contemplating it. And what's funny is the reason it came up is because we had a customer that was dead set on running the larger ones, but they wanted to run his spacers. And Dave, he doesn't even make them for the bigger TT shit. So all of his uprights and everything, it's all running the COM24N shit and these sort of packs, because it was basically like fucking pointless to run the $460, $470 bearings when the $70, $80 bearings were lasting just as much. And we have all the other characteristics still align, the strength and the travel, so to speak. So again, just something that is maybe a misconception, because some people believe they need to run that larger bearing. So I don't say, all the stuff that is on like DIY, etc. And a lot of what we do for clients is just running the 1.5 COM24N for the upright pivot of the bearings. Like that's that 1.5. That is. That, I don't know which one that in one. That might be the big TT one. That's a racer engineering arm. I think this is the big TT one. This is the old herb stuff. This one is running the big TT stuff. So this is one of our clients that wanted to run that bigger bearing. They're both considered 1.5 bearings. One's just considered trophy truck. It's the more expensive, bigger one. And one's just the 24NT. That's just a 24N. Same with these ones. These arms are just the 24Ns. They last, like I'm saying, totally fine. So we've been using those, you know, for the most part. So go figure, huh? So yeah, so there's one thing. Snap ring direction. Yeah, so on the lower arms, the snap ring direction is very important. So whenever you have an arm like this, where the bearing is horizontal, the snap ring needs to be on the bottom side of that arm, always. Now on the lower arm that is vertical, like, here we go, like this guy, the snap ring faces forward in the chassis. Same with, I'm trying to find a stage 2 arm. Same with like one of our stage 2 vertical arms. Again, there you go. So you want the snap ring facing forward in the chassis on the lower arm if it's a vertical bearing setup. Do not fuck that up. That is very important. This is the backside arm. And so, yeah, so that is one of those things. There are, I have seen, okay, so in the big truck stuff, etc., like you're not really using rod ends on the lower arm stuff. And then for the UTV based stuff, the upright side, the most common bearing used in UTV arm applications is going to be the 7/8 bearing. In fact, I can show you the specific bearing right now. That is what almost all of the UTV arms utilize, and it's these bearings right here. They're 7/8, and this is like the standard UTV cup that is utilized in most UTV applications for lower and upper arms. Spacers and bolts. Yeah, so for the big truck type stuff, trophy trucks, like I'm saying, 1.5 inch is the most common. ID makes great spacers as well. And then for CarTech, let's see here. I will show you what those big spacers are. Uniball components. There's kind of like a standard that it's a 4 3/8 spread for the 1.5 inch stuff. It gives you plenty of articulation. And they're pretty much all 3/4 inch bolt. I don't know when, you know, a smaller bolt, not necessarily a great thing. But as you can see here, there's some differentiation. So, 3/4 bolt, 4 3/8 stack. So this is a pretty common one that we use in a lot of lower arm settings. And then if you're running the bigger TT bearing, the 4 3/8 stack is available too in that spread. And so for lower arm stuff, this is like the very common spacer for big truck stuff. Now, in long travel kits and things like that, we have seen guys run smaller bearings. It all varies. In some of our sand truck type stuff, like our stage 1 sand truck arms, like these, they actually run a 1 inch bearing at the upright. There's no real need to go to 1.5 inch for something like a sand truck. It's not necessary. There's super light trucks. We get plenty of steering out of it, you know, and it cycles just fine. But for any of the bigger truck stuff, it's all the 1.5 inch bearing bits on 3/4 inch bolts. Like that sand truck one's a 5/8 bolt at the upright. But again, you're talking about a sand truck. It's half the weight. You know, it's you know, considered like cheese dick compared to like a trophy truck or luxury pre-runner, to be perfectly fair. And like buggy application stuff, a lot of them are 1 inch bearings, like the CarTech uprights that we like to use in some of our kits. We use, in fact, let me see if I can just pull one of those up. They're 1 inch bearings at the upright, and that is, you know, buggy based stuff. So like these guys, these lower arms are 1 inch bearing lowers, and it gets plenty of travel and it works just fine. But again, this is, you know, buggy application stuff that is not trophy truck based stuff. So like I'm saying, there's obviously some differentiation in that stuff. And it's all relative to the size of the vehicle and things like that. UTV applications, like I was saying, lower arms pretty much run 7/8 bearings. That is very common for the majority. They used to do 3/4 inch bearing stuff, but I mean, that was before like they started getting a little gnarlier. You know, once we started transitioning to like the Turbo S's, the Can-Am X3s, things like that, the norm was 7/8 bearings. Most guys stopped doing 3/4 inch bearings on UTV arm upright locations. So we'll talk about angle of the arm, bearing compared to travel, and caster. So I like to, for obvious reasons, you need to have the angle from a side view match relative to your camber curve. So that's why you see a lot of these arms, they'll have this bearing like angled up to a degree that would match the upright, etc. Like even in this ID arm, it's got some angle into that bearing upward. This one does. And so what that does is it matches the travel, relatively speaking. Now, another trick is here, you can see the twist. There's a twist in that bearing cup because I like to also match the bearing cup to the caster too. So at like static or like the neutral position, so to speak, the bolt is like at, you know, the optimized spot in the bearing, both with caster and camber curve. It's something I like to do. Not everyone does it. It's not really considered necessary to some degree. Some guys do consider it necessary. Like I'm saying, I do that where I match them, but you don't have to. And a lot of guys don't. And so that's just one way of doing it. So that's another thing to look for. So there's that angle in that vertical bearing. This is for that Jake Berkey front end. So this is like that mud racer, rock racer thing. There's that angle in there. Angle in there. Vertical bearing, so you know, to some degree it doesn't matter. But yeah, so again, you know, angling of the dangle appropriately to get all that to match nicely. Yep, there's one. But yeah, so there's that. So let's talk about some fabrication styles. Let's start with the Oreo / plasma table friendly stuff. So when I'm designing things that are plasma table friendly, my focus here is to make the plate work and the arm as simple as possible for the guys that can cut it on a plasma table in their garage, home shop, things like that, and easily snap it together and start welding with like a MIG welder or something equivalent. They could be TIG welded, etc. But the point being is we don't have the luxury of sending it out to like a laser house, do complex bending, all this crazy shit. We're trying to simplify the arm as much as we can. And so let's pull up, let's see. I'm trying to find a stage 1 truck. There we go. Here's our stage 1 truck one. And this is probably the most popular off DIY as far as bulkheads go, is the stage 1 truck stuff. We've sold a lot of these design files. But the arm, it just snaps together. And there's some really cool aspects to this in this plasma table friendly deal. So one thing to notice, if you look closely, all of it, like this arm has no bends in it. It's all straight plates. And I did that to make it as easy as we can to put together. And so you do have some sacrifices, so to speak, like these little lap welds right here, little joint welds that, you know, you'll sand it and weld it. And I'm totally fine with doing that because we have plenty of support structure, etc. These arms, again, are set up to be welded, you know, MIG welded, so it has like a pretty friendly deal for that. It can be TIG welded. Some guys definitely do that. But they are done in a fashion that the top and bottom plates just snap to the arm. And so why I'm doing this, again, is to create it to be as easy as we can to have a guy cut it on a table and just start snapping together. So if you've never built an arm like this or anything like this, I do my best in the plasma table friendly / Oreo style stuff to make it as simple as possible for guys to build these arms. And so I sacrifice some of the cool aspects or style aspects appropriately so that I can make it like pretty rad for them to do so. And so like some of the things I can get away, like I do to cheat this system because we don't put a lot of bending in this or any bending at all, is like this plate comes straight through. So what this allows me to do is make this straight plate come into here. You can weld that there, weld that to this cup. And this is all, pretty thick material, like 3/16 stuff. And then this plate has like a 3-way weld where all 3 of these joints get welded together. This guy gets welded there, then this has a lap weld there. And same with this back corner. Let me see if I have some more details on that. Because what I'd like to also do with these is organize the plates in a fashion that allows me to weld the interior. So so there's a cover plate that goes over this, but the cover plates are moved in this image, and what they can do is weld this internal rib to that bearing cup, and then they can put the cover plate in and weld it up. And so it creates a pretty cool way of getting that internal rib welded to the cup. So it's not just the external weld to the cup, there's the internal rib weld to the cup. And in the more strong arm, so to speak, or the more race-based stuff, you always want to have an internal rib welded to the cup, as well as obviously the external welded properly. So I create these sort of windows. Like here's another plasma table friendly arm for a buggy front end. Super fucking simple. It has a slight little bend in the arm. Otherwise, these plates just kind of come in. They have real minimal bends. This is all light plate work. So 095 to 121 terminals that you can easily bend on like a home harbor freight press. And the arm just snaps together with the little tab and slot stuff. And it's done in that fashion to be super simple. Also, because it's plasma table friendly, like when I'm doing the tab slots, I open those up. I'll get to that in a minute, but let's focus on just the style of this Oreo. So you have this sort of lip that you weld, like a T joint, so to speak, on all 4 sides. So again, we're not utilizing fancy bending in the arm or anything complex to make these as straightforward as possible. Here's another plasma table friendly arm for some rock race stuff. So again, here's another plasma table friendly arm with that cover plate in there. So they would weld that internal rib to the cup and then cover it with the plate and then weld this up to the other ribs, etc. This is just another gusset there. So there you can see like that internal side gets welded to that rib. And then, right here, he gets welded in there and then it gets covered up like this. So it's just a trick I can deploy in the design that allows me to get the internal ribs really close. Like this internal rib here comes forward and welds to this piece, and then right there, boom, you weld that up, then you put this overlay on. So it creates a really good bond from the internal structure to that bearing cup, and that's very important that you want to have your internal ribs bonded as best you can. And you'll see once you get to the more professional, higher caliber arms, they're going to have a lot more welding in it relative to the internal ribs to the external structure. And you'll see that theme start to develop as you study sort of all these other arms and stuff. So here's another good example of designing it in a fashion to where the internal rib can complement your welds and the other straight plates. Like this right here, although kind of a funky big weld, but again, you can get a lot of weld that attaches this outer sleeve for the Delrin to this rib and to this rib. So this whole joint right here gets all welded up, and then on this backside he pokes through this plate a little bit too to weld up there, creating a really nice structure with this tab slot on top. So you're really solidifying those bits. Even though this is plasma table friendly, we don't have to sacrifice some of the cool strength issues you can build into the arm, and it just snaps together. Very simple and efficient way to build these arms. The shock mounts just plop right on top. As simple as it gets. And this is a stage 2 arm. So we'll go to, So that's sort of like my plasma table friendly-esque style. Very popular for the do-it-yourself guys. Very popular for the guys that are building stuff with their buddies at home, small shops, things like that. And again, we sell these files on DIY, shameless plug. But just a super simple style that I like to deploy in these applications. Now, something a little bit more complex would be like on edge welding, which you can see right here in the stage 2 arm. Right here. So this is not a Oreo-like structure that has that lip that hangs over. These plates meet up in a fashion that creates a nice weld lip. I can also, so on all the stage 2 stuff, we're now venturing into the world of laser houses that will cut and bend these arms appropriately. So I can do a lot more complex bending. I can get away with that stuff, whereas we're avoiding that with the stage 1 plasma table friendly type stuff because it's hard to take the lower arm and bend it up and things like that in a home shop without the complex sets of dies and the experience like the laser houses have. So the irony with this is it's significantly easier to design like more complex arms than it is to make like the plasma table friendly shit. And I would have thought, years ago when I started down this road, I would have thought it been the inverse, but it's not, because the plasma table friendly stuff, I really got to be careful how I'm doing it because I can't be bending all this plate work, and I got to still maintain the strength and the structure of the internal ribs to welding to the bearing cups and things like that. So you got to be very careful with getting everything dialed in, whereas like the more complex arms, you're kind of really relying on the laser houses, etc., and they can do a lot of cool shit. So now you can start incorporating all this cool bending and forming and things like that give you a much cooler style and make it your job easier as a designer, because now you can fudge stuff into place to some degree that you don't have that luxury because you're taking out some of these facets that you can deploy in the more complex stuff. So the irony here is, although the more complex stuff takes more time to draw, it's a lot easier to draw because you have the liberty of this stuff at your disposal. Whereas like the plasma table friendly stuff becomes a lot more of a headache because we're still trying to uphold, performance characteristics and strength characteristics, but not have all the other complexities coming from, experienced guys at like a laser house with the forming. So there's just some insight into sometimes that's just a total fucking headache, But yeah, so this is an arm that would be on edge welding, so to speak. And this is a stage 2 arm, so the whole bottom of the arm is bent up. The welding, and it does produce a little bit of a cleaner arm style-wise and look-wise. So there is some trade-off with that. The stage 1 plasma type stuff, or PTF that I like to call it, or Oreo style, is definitely a little bit more of like the, I hate to say it, but like a lower caliber on the style scale. As much as I do love the plasma table friendly stuff, it just doesn't have the same style as a nice formed arm. It just doesn't. So there's one of your trade-offs. But yeah, so with the forming, we can start to get a little crazy with the bending, things like that. The other thing too is on these stage 2 arms, I can make it out of thinner material. These are all designed to be 4130, and the vast majority of these guys are going to be TIG welding this stuff. So we have the luxury of using a lot thinner material. The arms end up lighter weight, things along those lines. And so like on this stage 2, you can see all those internal ribs really diving into that front bearing cup area, and it creates a multiple layer section of welding to this internal rib with two internal ribs coming to this cup. And then I offset one of the ribs so I can dive a fucking ton of weld bead in there to penetrate both ribs, to that bearing cup. And another trick I like to employ with some of these styles. And then again, here's another way of doing it too that I enjoy with, getting internal ribs welded to the bearing cup. And we'll talk about some variations with internal ribs or not internal ribs. But this is just a way to have it weld nice. Another example of like an on-edge weld, I think here it is. Like the Master Fab arms, those are on-edge welded with some internal ribs in there. And they're doing very similar to what I was just saying, where they have caps that come into place that help them weld those ribs to the bearing cups. But let's see here. Like Kibtech, he comes to mind for like a standard, style arm in this fashion. All 4130, like his long travel stuff is all done in that style, but he ain't plasma tabling any of the of his kits per se. Come on, where's some welded lower arms? It's probably been a while since he's even posted those pictures of welded lowers. Fucking Ryan is selling carbon shocks. Oh God. Well, when you struggle to get shocks, you got to compromise somehow, I guess. I'm failing miserably on this one. It's been a really long week. If you don't notice, I am a lot more tired today doing this episode than I normally am doing this stuff. But I'm trying to uphold every week getting a chunk done because there's so much stuff I want to get through that it's taking a lot longer than I initially thought. But that's just how this game goes sometimes. And again just failing miserably on getting a fucking example of what I was trying to fucking show. And he makes all of his lures like this too, and he doesn't even have any recent pictures of it. God damn it. Well, anyways, the point being is, I mean, there's some, but I'm trying to show like he's done this where he takes like nice pictures of the welded arms, you know, all in a row or some shit, and you can really see that style. Well, there's an upright, but same deal. So it's that edge weld, so to speak, style, and so that is again another way of doing it. And there's a lot of guys that do run that style. Like this is a racer engineering arm again. That style, and it's so much cleaner than the Oreo style, so to speak. So a lot of the race trucks type stuff, they're not running Oreo style arms. They're running more race-based arms. There you go, on-edge welding, older Herbst arm. Even the newer ones, I want to say, are the same way. The ID, again, same thing. You know, this is that edge weld, and they have, you know, bending and forming they're utilizing to make it all a lot cooler than Oreo style. Again, same thing. You know, here's one of the newer Herbst ones, on edge welding, welding on edge. Again, when you can utilize the bending and things like that, it definitely helps. It's pretty rad. But yeah, so that would be a different style. Tube and boxed. Okay, so this is kind of like one of my personal styles. I don't know too many guys doing this. I have seen people do this before me, to be fair. This is the arm for Izzy. So let me find, where are those T4 arms? This is something I like. This would be my personal style. And because all of these ones I've been showing you so far are just like standard boxed type arm stuff. Again, here's a Tisco, and we'll come back. So I'm going to talk about some of the internal ribs here in a minute, but I'm trying to go through the outline to some degree. So you understand what Oreo style arms are and the non-Oreo style arms, or what we call on-edge weld arms. So here we go. This is our T4 trophy truck arms. And I put tubes as my main starting point in the structure. I like it because it's different. I also like it because it has a very soft sort of edge and a very strong sort of edge leading the arm, so to speak, and trailing the arm too. And it allows me, like, those tubes are 120 wall, and then the rest of that plate work will be like 095. You know what I mean? Like, I can make these arms lighter with this sort of structure, this base structure in place for like a 6100 arm. And again, this is just a personal style of mine. And I don't know anyone else really doing this. I haven't really seen anyone else doing this. But, you know, different strokes for different folks. It's just something I think is really cool. Oh, and yeah, since we're on these, so yeah, it is a miter junction in that arm. A miter, some call it a partition, is this flat plate that's welded. Oh, thanks, wife. More water. Thank you, love. Yes. And so the partition is welded into the arm. And you have to do this if you're mitering anything, whether it's in the chassis, arms, links, whatever you're doing that has a miter junction, you need to have a partition or a miter plate in there. And what that does is a bulkhead plate. You know, there's different names for it. What that does is provide a few aspects to this. One, it's a great backing to just dive a fuckload of weld in there. As you can see, it creates this sort of valley because you'll chamfer the tubes. In the computer, they're not chamfered, but if I'm fabricating that, I'm chamfering that 45 in the tube, creating a mega fucking valley. Just lay a root pass in there, and then second pass all the way around. But it creates a great backing for putting some good heat into that arm and weldment. And so on top of that, the other thing you have to remember is you got to put a hole in that partition. You can't not put a hole in there. So to properly do a miter, so to speak, or partition, you're going to have a hole in it. And you can go back to even like I had shown before, and we just stumbled on Derek Dump. He showcased this. It was in the same deal. Just so you don't think I'm fucking crazy, but the hole, he does a smaller one, and I think he made those partitions by hand when he did his. Let's pull this image up because we just passed this a few minutes ago, or 30 minutes ago, when we were looking for the fucking arm pictures, and now we're going back through this again. God damn it, Jason! Should have probably had this image, already put into that folder that I've been using, but whatever. It fucking happens. So yeah, so here's a perfect example. So you put the hole in there. You want the hole, and what that does is that helps gases transfer so that you don't accidentally overload a cylinder, so to speak, with too much of the inert gas that it wants to blow the fuck out. And any of the TIG welders that deal with this stuff know exactly what I'm referring to. So if you're doing a miter partition, that there's a few rules you got to have in place. One is the miter should never be thinner than the material wall of the tube. And in some situations, you want it thicker. So, for example, if I'm running 120 wall tube, the miter's 120 wall. 095, the miter's 095. If I'm running 045 or 030 wall tube, and yes, some of these big trucks have that thin wall shit in there, I usually make the miters like 065 at a minimum. So even though I'm running 045 wall tubing, I'm not going to make the miter 045 wall. I will make the miter 065 wall. And then we punch a little bit larger hole, but this has a hole in it too. And what that does is it helps that gas transfer so you don't get the dreaded fucking blowback. And so those are the two primary requirements for these miter or partition plates. One, the material thickness at a minimum has to match or can be a little bit thicker. And two, you got to put a hole in there at a minimum, like an 1/8 inch hole. I usually go a little bit bigger because why the fuck not? We're lasering them anyways. And that'll help with the decreasing that blowout effect, so to speak, when you start getting with all these fucking junctions and TIG welding the shit out of them. So yeah, so there's a little rant on the miters themselves. And so that is my style on the T4 stuff. And you can see I have some pictures in here of it in the fixture and kind of how I build them. There we go. So they start off like this. So you got your main tubes in place with your bearing cup set, your chassis side set, all that good stuff. You go ahead and weld up the miters, weld up to the cups. You start inlaying the shock mounts, and then you start building the plate work in the arm from there. And you can see I'm running some plate work off the tube up. So I'm creating some internal structure as well. And like a lot of this will be 095 material. The arms are 120 wall. So like we're using thinner material than we would on other stuff because I have this sort of 120 wall tube base, so to speak, in place. And then you can see the arms starting to be built out appropriately. But yeah, so just some tidbits on how I like to do some of those arms. There you can see the tubes underneath. So by the time it's done and welded, you see the tubes, but not really, because all those plates are like tangent to the tube surface. So once it's welded, it creates a nice smooth surface. It just looks like a nice rounded bottom. And, it looks like a sheet metal arm from the top, and it just has this main tube structure in the bottom. And I think I'm the only one doing this. I don't know if other guys are. I don't care if anyone copies this style, so to speak. It's just something I like to do, and I'm a fucking nerd, so whatever. As you can see, there's a lot that are not done in that style. So let's review. So this is one of the Herps arms, and this is it's all sheet metal arm. As you can kind of see, the construction of it, so to speak, is done. And so these don't have internal ribs, I'm pretty sure, in this situation. And that's not uncommon. So that is common. Like here's an ID arm that's similar. And these are what I would consider called pocket arms or shock pocket arms. where the primary construction is basically this shock pocket assembly, and then you build the arm out from there. In a way, my T4 arms are similar. So this is sort of like that shock pocket you can see, and then the arm is, the pieces build out from there, as opposed to running full length ribbing and then building stuff laid into it. So this is that shock pocket style where the pocket is built and then the arm's built out from there. The inverse of that would be like this style here, where I'm running full ribs that actually are the shock pivots and then coming back. Now this is a little bit gnarly. This arm is going on a heavy truck, and the client did request it to be more on the robust side. So this is definitely a little bit more on the robust side arm. Like I'm saying, we've got serious internal ribs, and in these situations, like this ID arm does not, and this Herps arm does not either. And I have drawn arms in this style too, but I didn't put any of those pictures in there. One, I don't think we're supposed to show those, and two, like this style is very normal for a lot of these big truck stuff. And again, it could be, you know, perceived as monkey see, monkey do. One I did do though is in these sections coming back, I had diagonal ribs in here that were kind of hidden, so you didn't really see the weld line. It was coming from like this weld line to the interior bottom, so it's kind of like one of those cattywampus deals. I have done that, and that was kind of cool and worked out pretty rad. But these hollow based main arm ones, for the most part, they work just fine, and they rarely fail unless you hit stuff per se. So at the same time, like they're kind of to some degree considered pseudo consumable arms, because the teams that are running this type of stuff, it's really not a big deal if they replace arms like every season. Like it's totally in the budget. You know, you're at a level where that's not going to make or break your race season. So the argument can be made, by making the arm as light as possible, you can sacrifice some of that, you know, aspects where it could pseudo be a consumable, to where under almost all racing conditions you're fine, but if you fuck up as a driver and hit something, you might wad the arm, or you might bend the arm where maybe you wouldn't with a more robust arm, but that trade-off is like you shouldn't be hitting that stuff. So the argument can be made that these arms are definitely more than proper, even though they don't have all the internal ribbing, so to speak, as some of the other arms I've showed you. That doesn't necessarily mean they're wrong or done inappropriately. It's just in some of these fashions of racing, it's totally acceptable for this to be considered kind of a consumable to some degree. And again, there's nothing wrong with that. Like look at that, the Herps arm too. One of the original Herps arms. Again, same thing, you know, these are hollow shock pocket-esque style. And, you know, like I'm saying, it doesn't mean that because it doesn't have the ribs in there that it's wrong. It's just a different way of doing it to some degree, that it can be a consumable, you know, and you shouldn't be worried if you do tweak one or bend one, because the vast majority of off-road racing or drive time, so to speak, the arm's going to be totally fine in normal operation. If you fuck up and tag or rock or something you shouldn't have, well, you know, that's a different discussion, so to speak. So the weight reduction relative to that is part of the equation. Here's another tube arm. This is for that fucking gnarly moon buggy Jake Berkey thing that is like 250 wall material. So these are like gnarly arms, very gnarly. So here's another trophy truck arm where you can see the internal ribs coming back in that fashion. So again, here's another one we did for a client where you can see the ribbing in it going back. And now, so in a lot of these arms, this one I think is all 1/8 inch, if I remember correctly. And this was going in a heavier truck, definitely a heavier application, bigger pre-runner per se. And so this arm I think is almost all 1/8 material, other than some of the overlays. Oh, there's a good shot of that. This is the arm I did for Ross King. This is all 095, this arm. And the internals were 095 as well. And you can kind of see the internals. So this is obviously not a shock pocket style arm. The arm is built like a big clamshell. and then the shocks sit and they locate in some of these little tabs. They click in place on top of the arm. This was a request from Ross. This is how he wanted it done. These arms end up being super lightweight, but pretty stout because I have, I appropriately did this to where like everything was set up with the internal ribbing and things like that to be pretty appropriate. This is a stage 2 lower arm. You can see the internal ribbing in that. Again, it's all 1/8 inch internal ribbing. This is all meant to be out of 4132. So these are not like mild steel arms. I'll show you some of the mild steel arms here in a second. So we'll go through some of the material thicknesses, then we'll start talking about the tab and slot, and then the pocketing of the internals. So yeah, stage 2. Again, here's a good shot of getting the weld to the bearing cup on that internal rib before we cap that end piece. This is all 1/8 inch. And stuff like this, even though you're going to TIG weld the arm, you could MIG weld that internal. Crank that MIG welder up and turn and burn those inside bits. You'll weld it to the cup here and weld it back about 1 inch on top and bottom as well. This is a plasma table friendly sand truck arm. These are all just 1/8 inch material or 095. You could do this out of 095 4130, or it could be 1/8 inch mild steel, and it's Oreo style. Here's again just another shot of that same arm. Like I was saying, you can see some of the internal ribbing. All this is 1/8 inch material. 1/8 inch material. This is a Tisco arm. I think this is all 1/8 inch material too. It's what it looks like. So you can see how the ribbing is done in this. Arguably maybe a little bit on the overkill side, but fairly stout. And it looks like this is done where these ribs pretty much are the full length from what it looks like. You know what I mean? Similar to how I was just showing you with some of mine. This is just one of the all-wheel drive sort of rock-esque buggy arms. This is all 1/4 inch material. So these are meant to be a little bit more ground and pound, thick as fuck, because this is meant to be a little bit more in the rough category. So, this is one of our plasma table friendly buggy ones. So the internal ribs on this can be 095 or they can be 1/8 inch. I have 2 different versions of this arm depending on what the like. If it's a 4-seat buggy, they'll go 1/8 inch. If it's a 2-seat buggy, they'll do 095. These are the truck ones. These are the plasma table friendly truck ones where the top and bottom plates, most of the guys are cutting those out of 3/16, and then the internal ribs are going to be all 1/8 inch. So all the vertical plates will be 1/8 inch. Top and bottom plates will be 3/16. These are the plasma table friendly truck lower arms. One of the more popular ones on the DIY site, definitely. And again, you could do it out of 4130 or mild, or you could do the top and bottom plate out of 1/8 inch and 4130, depending on the weight of the truck. But we've got guys that have been running these arms for years in fucking full size like luxury pre runners, like big truck stuff, crew cabs, extended cabs, stuff like that. Fucking MIG welded 4130 arms. I know some guys have done them out of mild steel too, to be perfectly fair. This is just, again, my T4 one. Like on this, like we have a 6100 that we're doing right now where, these tubes are 120 wall for the bottom of the arm, and pretty much all this plate work, other than a few of these internal ribs, almost all of it is like 095 with some 1/8 inch for the most part. The overlays are like 065. So you can kind of see what's going on there, how I have some of the internal ribbing, lacing, and then like I had showed you before, those have like internal ribs that connect to the top of the tubes as well that go forward. Oh, so here's another example of welding to the bearing cup and then putting that cover plate over so that you're getting all of those internal ribs welded. Again, here's another one before the cover plate goes on, welding to that bearing cup with the internal rib. This is that arm. So you can see these bad boys right here get welded in to the bearing cup on front and rear. Then it gets capped, and same with the rear sections too. And this one is, these ribs are the full lengths of the arm. So this rib right here comes back, comes along this side, comes all the way forward and welds the cup. So these ribs are welding cup to cup, so to speak. So welding to this cup, back to him. Same with this exterior one gets welded cup to cup. This one in here, these 2 interior ribs. So this shock mount right here gets welded to the cup here, gets welded to the cup there, and this one comes back and gets welded to the cup. Then obviously your side plate. Very robust. A lot of welding, but very robust. So there's a good example. You can see the cutaway to weld that internal rib, the cutaway to weld the internal ribs to the cup appropriately. These are just some of the tricks we deploy. So here's an all-wheel drive lower arm. Now these are definitely on the gnarly side. The all-wheel drives have a lot of unsprung weight because of the portal setups, and an all-wheel drive portal setup like this. And this is all, these arms are primarily 1/8 inch material. These all-wheel drive arms that we did for towers. There's that arm right there. This is all like 1/8 inch material. And they're not terrible. These are some super lightweight 7200 arms. Like this is 1/8 inch material with some 065 overlays. And I want to say these tubes were like 095 wall. Super lightweight, 4-cylinder, 7200 chassis, which we'll be talking to the owner of that soon too. This is that same, like I was saying. I do have lacing inside of these that go from the tube up, and then it gets covered. So you can see like this rib comes along this whole path and gets welded. On top of those tubes being in there. And you'd be surprised, these are not that heavy. I can get away with a lot of 095 as opposed to 120 wall or thicker. So yeah, so there's some good rundown on some material thicknesses with the tab and slot. I'm sorry, with the internal ribbing. Now let's talk about the tab and slot stuff. And again, this is very important. You want, so every single, so first let's talk about the variation in how I design tab and slot, whether it's going to be plasma table friendly or laser cut. So for the plasma table friendly stuff, we'll come back to those. Those arms, tab and slot wise, and when I say tab and slot, it's all this stuff where the arms click together and show the internal ribs and the welding in that. So, you know, these lines on top, and what that equates to is you can see these little ridges that are raised. So there's two things to take away from this. You have the height of the rib relative to the thickness of the plate it's going into. You also have the tolerance of the cut around that rib from that top plate. So on plasma table friendly stuff, we like to have 20 thousandths of clearance on the sides and 50 thousandths of clearance on each end. And that seems to be a good number for the plasma table friendly stuff. On the stuff that's going to be lasered, we run it. So what'll happen here is we'll have 50 thousandths of clearance on this end, and 20 thousandths of clearance on the sides in the computer. And that's for the plasma table friendly stuff. For the stuff that's going to be lasered, like these arms here, we actually run 10 thousandths on each side and 20 thousandths on the ends. I find that is a pretty good standard for when shit comes back from laser, it being pretty titties. So there's some quick variance in that. Now, the other thing too is when you do the tab and slot stuff, you want to get a lot of welding between the internal ribs and the top plate. A lot. So what I like to do is space things off appropriately to where like there's only a 1/2 inch that's left in between some of these slots, if anything. And that's pretty common. So I'll have a lot of long welds and then 1/2 inch sections. What you don't want is you don't want to have small bits of weld and then like a 2.5 inch or 3 inch section and a small bit of weld and then a section. You want to avoid that. The minimum you want is it to look like this, where it's like a 1/2 inch and then 2 or 3 inches and then a 1/2 inch and 2 or 3 inches. If you have too much in between the weld spacing, so to speak, you're not going to have enough connection from the top plate to the internal rib. And what can happen is they could buckle and fail because then in that section, the top plate is in essence not really getting the strength from, or the rigidity, so to speak, from the internal rib. So the cattywampousness wants to buckle and fold easier. So whenever you're doing the internal ribs, like I'm saying, a general rule of thumb is At a minimum, or I'm sorry, at a maximum, you only want like a 1/2 inch. You want these big, long chunks. Now on the interior here, it gets welded up in here from the interior. You can kind of see. So that's why it starts off a little bit longer looking. It's an optical illusion, but it gets welded a little bit deeper, so to speak, in there. And so you'll see that trend with a lot of the stuff I design, and you'll see that with other people's designs too, or they go even gnarlier. So to go even gnarlier, you'll do stuff like this, where like almost the full thing is exposed. Almost the whole rib, other than just a few bits to help click it together. See that? Otherwise, that full rib is exposed. So some of the race stuff, or the more important race stuff, we want to weld the full length of that rib. Now, some of it I'll do partial, but again, I'm doing a decent chunk on that. And the others, we're going pretty full fucking length. So that is what you want to see. You do not want to see the inverse of that. Like I'm saying, it's almost like the internal rib isn't even fucking there. So you do want to watch out for that aspect. And again, I'm not the only one doing that. Let's go to yeah, like even on the older shit, like the Ross King stuff, I have a lot of the rib gets welded in. A lot. Like I'm saying, I'm only doing a max of a 1/2. And then like look, they're doing fulls. Just like on the other arm I just showed you, on my T4 arm. It's full rib weld length. So the fabricators might bitch because it's a lot of welding. But again, the minimum I do is just that 1/2 inch, and then several inches of weld, and then 1/2 inch. So you minimize the space between. And like I'm saying, the maximum I do is a 1/2 inch. Full weld lines. Like the more race stuff, I'll do full weld lines. Like our T4 arms are full weld lines. Like here's the Herbst one. Again, it's a full weld line. So on the again, full fucking weld lines on our T4 arms on the main ribs. So yeah, so there's another thing you want to watch for, is you need to have plenty of weld between it. Or you, like I'm saying, you need to have only a small bit and then long sections of weld in the small bit, so that you're maximizing the connection, so to speak, between the two. What you don't want to see is the inverse, where you have like 1 inch of weld, then a space, and 1 inch of weld, and then a space. You want 1/2 inch of space, several inches of weld, 1/2 inch of space, several inches of weld. And then the depth. So the plate depth in there is important. So if you have like 1/8 inch thick internal ribs, and you're going into an 1/8 inch thick top sheet, and you want to MIG weld it, or TIG weld it for that matter. And the TIG welding, some guys get a little bit weirder with it, so to speak. But with the MIG welding, like that rib will only be, like the way I like to draw it, it'll be like 50 thousandths tall, so that it's below the 50% line of the material thickness, so that you're diving your MIG gun, your MIG wire in there, and you're burning the side walls of the rib and melting into the rib and the sidewalls of the top plate / bottom plate. So let's see if I can find a picture that showcases that. Yeah, so here we go. So this top plate's an 1/8 inch. The rib height is only like 50 thousandths, so it's below the 50% mark, so that I can weld and dive the weld into that sidewall pretty good. And this is definitely for MIG welding. Like for MIG welding stuff, you want to be below the 50% mark. You fucking have to be, because you have to be able to melt that sidewall in and get that MIG bead down in there and melt all that stuff together. On the TIG welding stuff, some guys prefer to be like into the 80 percentile range. So on like an 1/8 inch plate, they're going to make the rib like 90 thousandths tall, or they prefer that. And the reason they prefer that is, in my opinion, a little bit on the laziness side, because what they're doing is they're just trying to single pass that with minimal rod add and just like melt it in. It's not the best way to do it. You still want to be below the 50% mark, even with the TIG welded arms, because you want to dive like a first pass of weld in there and melt that sidewall into the bottom. So My preference is the height of that should be below the 50% mark of the plate it's going into for your tab slot. And that's so that you can appropriately burn the sidewall together with the internal rib and back up to the other side. Otherwise, like I'm saying, you're kind of not getting the greatest connection between those plates in that junction. And some guys, we do have clients that are somewhat guilty of that. They require us to draw it closer to like the 80% mark, so it's much gnarlier per se. And that's fine. Different strokes for different folks. So yeah, let's go into pocketing of the internals. Another cool topic, disco arm pocketing. So every time you have internals, we always pocket them. Unless the arm is too thin, it won't work, so to speak, or becomes a headache. But you always want to add some weight reduction in there. There's no reason not to. Again, another reason why you want to have small space, a lot of weld, small space, so that you don't have like a weird situation where the arm wants to kind of buckle inside there. In some aspects, if you do it the inverse, it's like you're not even putting the fucking rib in certain sections. Like, it's pointless. So again, you got to pay attention to that. If you see it done the inverse of that, where it's like fucking, 1 inch of weld, 2 inches of space, 1 inch of weld, that's fucking wrong. That's fucking amateur. Get the fuck out of here. And stop whining about, it takes too long to weld. Again, there's like 1/2 inch of space, 3 inches of weld, 1/2 inch of space, 3 inches of weld. Maximize that connection between the ribs and the top and bottom plates. Again, here's a racer engineering arm, 1/2 inch of space, weld. Some of them are full welds, But yeah, so let's talk about the internals and pocketing the shit out of them. So yeah, like on this arm, again, pocketing. So this is just circles, standard issue circles. For stuff like this, I like to be, the minimum distance between the circles would be like a 1/2 inch. Minimum distance between the circle and sort of the top plate would be like a 1/2 inch. So I think that's a good metric, maybe 400 something thousandths, but 1/2 inch is pretty good if you understand where I'm going with that. Like, this distance in between the ribs is a 1/2 inch. This distance here is like a 1/2 inch minimum. Like, that's pretty common for a lot of the arms I draw. And if we can't get a good circle in there, like this starts to thin out in this section of this arm, we don't pull the weight out of it. But in a lot of the other sections, you can see 1/2 inch, 1/2 inch, 1/2 inch of clearance, so that you don't accidentally pull too much material out and create a situation that would be unpleasant strength wise. Here's one again. You can see they're using 2 holes in some of the smaller sections stacked. Very common. I've done that a bunch of times too. But again, you can see, that's roughly a 1/2 inch, roughly a 1/2 inch there. A good measurement on circles. The other thing I like to do too is I like to use triangles in a lot of internal ribbing. So I will draw triangles in, and again, it'll be like 1/2 inch around for stuff like that. It's another way of doing it, and it's kind of a cool way of doing it, in my opinion. And in some situations, I'll use ovals. But again, on the oval stuff, you got to be careful. This is like the max oval I would go distance-wise. When you get too far, too elongated of an oval, it's like the borderline, the rib is in there. To be fair, on this specific arm, like, it's pretty fucking stout, as is. So the argument could be made that those internal ribs, don't necessarily even need to be in there, because it's very similar to like some of those other arms I was showing you where they're hollow, like the ID arm, etc. This one has a rib, so we're already adding some structure in that fashion. So lightening it up a bunch. It's all 1/8 inch internal ribbing in this arm. But this is the max I would go oval elongation wise. But let's show you some more of like the triangles, which is my personal favorite is the triangles. And definitely have some other examples of that. Let me just find those. here you go. So here's some good examples of how I do the triangles with a 1/2 inch. This one's just a straight fucking window. Again, a lot of this is like so fucking overkill rib wise. This arm is actually 3/16 ribs. Now I remember who I did this for. Yeah, this is all 3/16 internal ribbing in this specific arm with machined fucking spacers that get welded in all bitchin' for the bolt holes. Weld washers, basically. 17.4 weld washers. And this one is all triangles, half inch minimum on the triangle stuff. And you can kind of see how I get it to where it complements the bits. But yeah, so there's some different styles. You got circles, ovals, triangles. Again, circles. Again, same with the 1/2 inch deal. Circles on this. A little bit of ovals, a little bit of oval going on. But again, you don't want to... this is a Tisco arm. Yeah, you can see he's got circles going on. A lot of circles in the internal ribs. Taking some of that weight out for no reason. These arms don't have it because these arms are really thin. So they're only like a fucking 1.25 inches tall. So obviously the 1/2 inch mark makes that not viable. These arms are thicker, so they have it in there. And these do too. I showed you those, the T4. So there's a few different styles of doing the arm internal bits, that you could totally tackle and pocket. Oh, another trick too is back in the day, in some applications where the arms were big enough, we would dimple die. We would do like 3/4 inch circles and dimple die them on the internal ribs when the ribs were like 095 ribs and shit like that. And I'm working on some UTV arms for my XX that are like the race arms. I actually have some plasma table friendly stalkers that I'm putting on shortly here, but are stock replacement. But I'm working on a race kit for the XX that the internals on those are actually dimple die holes for the internal ribs, because the internal ribs on that arm are 065 wall. We're trying to maximize strength and weight on that XX application. So that's another trick. And I just realized I completely spaced and did not put the pictures of any of the dimples in internal wise. But basically, if you know what a dimple die is, you're taking, like a circular hole, like one of these, and dimple dyeing them inside the arm to add a little bit more rigidity to it. It's fucking baller as shit. It does make the arm a little bit more of a headache to put together, but fuck it. It's fucking cool. And like on those UTV arms like I'm referring to, like mine, I will eventually have pictures of it and shit once I get it done. And those are dimpled internal like 065 ribs on like the rear trailing arm. And that's going to be fucking cool to show, because some of those dimples end up being like 1.5 inches diameter, because the trailing arm gets big in the back of the XX. And so that whole flare, I mean, it gets fucking hidden, you never see it again, but like it's fucking rad. And I've seen other guys do it too. So like again, that's not something I invented, dimple dyeing the fucking interior ribs. That's something I totally fucking stole from older guys than me. But yeah, so there's some rundown on internal rib variations and differences. Weld washers, machine, or laser plate. Cool. So again, some arguments in whether to do weld washers. So here's like ID does machined little bits in there. They get welded in. So those are his version of a weld washer. Really nice with holding the bolt. If you can afford it, obviously it's more expensive to go this route. But, different strokes for different folks. And that is a really nice way of doing it in arms. Like on these arms, we just have laser cut weld washers or overlays for the pivot. So it's double stacking like 1/8 inch material or 1/8 inch with 065 overlay plates. These are Clevis lower arms, so they do not have that in there. These are laser cut internal weld washers, so they're welded on the inside of the arm. It's the laser cut piece of material that the bolt goes through. Again, pretty standard. On these arms, I don't remember if on the T4 ones I have laser cut ones or we did machine ones, but it's not uncommon to do machine ones. So like here's some machine ones we did for a client that go in. similar to like the ID ones. The cool thing with this is you get a really nice bolt surface, and you weld this up with a spacer in there that holds it all fucking bitch in. So it is a little bit more on the baller side. It definitely adds cost to building the arm and some time, as opposed to just doing like a laser cut overlay or laser cut, circle, so to speak, like we've done on a bunch of different arms. So different strokes for different folks. Companies like CarTech do sell them. I do have some I'm machining right now for myself, that we will sell on DIY. But let me show you like the CarTech ones, because they do make, I guess you'd say like standard issue weld washers that a lot of guys use in a lot of different arms. And it does provide a nice machined fit surface for the bolts. And we do use them. 1/2 inch, 5/8. Most of these shocks are running 5/8 bolts for the big truck stuff on big bypasses, coilovers. And this is a flat one. So this one just welds flat to your laser plate, so to speak. The inset ones, they're not terrible. The thing that does suck with the inset ones is we have seen variances in material thickness to where like the 1/4 inch material is not really 1/4 inch, or the 1/8 inch material is not truly 1/8 inch, or the 3/16 is not truly 3/16. So sometimes we see some little variance, 5 or 10 thou in that. But if you're putting in the appropriate, spacer when you're building the arm and welding it, you'll be fine. So again, different strokes, different folks, not the end of the world on that. Still, a lot of guys just run the welded fucking laser cut plate ones. Like these arms just have laser cut plate that gets welded in. Nothing too fancy, but you definitely want to layer that up a little bit to get you some girthiness on the bolt shank, not the bolt thread. These are all shanked bolts. And eventually I can go through the shanking of the bolts, but I feel like almost everyone in the industry knows bolt fucking shanking, so it's kind of pointless to go through that. But yeah, so there is, again, some variance in whether or not you do that. If you want to do it proper, I personally like using a weld washer or a variation of your own, like what ID does. It just adds a lot more cost. But again, it's just like everything with this industry. Like this client, these are all 17.4 pieces that get welded in to 4130 plates. And it creates a really bitchin' nice surface for the properly shanked fucking bolt. I mean, it doesn't get any better than that. So if you're really anal about the properness of it, you can do that. You just got to factor in that's going to add several $100s to the arm to do it, as opposed to just a fucking laser cut plate. Like these, I'm pretty sure are machined little bits that he did. David ID has his own version. The other cool thing too is like with how Dave does it is he opens up the pocket. The pocket ends up being a lot wider because the shock spread on these is 1.5 standard for these types of shocks. And so for obvious reasons, this offset here could be like 400 thou or a 1/2 inch. And so now you've just opened up that pocket a ton, which definitely makes fabrication of the pocket a little bit easier. So, again, there's pluses and minuses to everything. It's a lot more expensive to machine these and put these in there, but it does have some benefit to it. And there's a perfect example of both the size of the pocket benefit relative to the fabrication ease of the pocket internals. Plus, it gives you a really good fucking machine surface to put a properly shanked bolt in. But it doesn't, even like these Herbst arms, like these are Herbst ones. Like they're just using the laser cut plate. You can see how it double stacks in there, the thickness of it, and it's still pretty stout, So again, with a properly shanked bolt and this properly done with the proper bolt in there, it's going to be just fine, So again, different strokes, different folks, another way of doing it. So yeah, now let's talk about wrapping the bearing cups and the bushing sleeves. Sometimes we don't wrap them, but for the most part, we do. That is considered common for like the race car-esque stuff. So what we're referring to is this wrap around the bearing cup, wrap around this bearing cup. And most of the time, like this ID arm is not wrapped, but the argument can totally be made this arm is playing strong enough. Like you're not going to tear this out. He's got 2 ribs internally welded. Eric over there is a phenomenal welder. He still welds in the proper way, not this fucking pulse setting bullshit all these Instagram kids do these days. Here again, you can see the wraps. Now on these wraps, my personal style, like on this arm, this wrap is a 1/16 of an inch material. And then what I do is I put a hole in it right where that other crossplate meets that bearing cup to just fucking put a ton of nice material in there and get all that tied in even better. And then tie it into the other bits. So that's something I like to do on the bearing side. And then like even for like these guys, like I put a hole in this guy where it meets up with the internal rib weld. Again, on this overlay right here. Again, another trick that I like to deploy to get some nice weld surface attachment into that stuff. So like here's the bottom of that arm. See that? A little more weld surface attachment to it. Not everyone does that. That might be just something weird that I do. Again, here's another perfect example right there. Let's see. In this situation, they're cutting holes in it. Again, gas transfer, etc. And then the wraps will cover those holes up. So that's another way of doing it. It's an older arm. Here's another way of wrapping it. Again, pretty clean way of doing it. Here's some other wraps that I've done. Again, around the bearing cup. So the bearing cup gets all welded in, all that kosherness, and then that wrap will go on. See, you can see that wrap. Here's that overlay. Wrap around. Most of these are all just 065 wall for the wraps. Yeah, here's that Ross King arm with the wraps. Generally speaking, a lot of the race truck stuff is going to have a wrap on it. The argument can be made a lot of times you can get away without it, but the vast majority of the guys I designed for it prefer to have the wraps on the bearing cups. Like we even do it on this stage 1 arm because the guys like them. Again, there. Just really helps with that connection, solidifies all that bullshit in place. Yeah, here's wraps on our T4s. T4 lower wrap. Helps tie that tube to that plate work as well. Yeah, it starts to really burn and turn all that in. So yeah, again, different strokes for different folks. Just some of the stuff I like to do with the wraps. And one thing to note too is process of welding the arm. Let's review some of that. So cool. So on this specific client's arm, I have a process for doing the arm. Or wait, am I going to mess this up? I'll mess up my outline. No, we could do this. Yeah. Well, we'll just change that. So now let's go into this sort of well-processed order for doing this. It looks like we're only going to be getting through the lower arm stuff. The upper arm stuff we're going to save for next round. But, so yeah, on this, so this client, the way I like to do these types of boxed arms is in stages. And I do that because I want to minimize all the fuckery with the ends, so to speak. So the critical stuff I want is the chassis spread to be dialed, and then obviously the bearing cup on this side to be dialed. So in this situation, this client is going to build this arm on the table just like this, get it all snapped together, weld it all out. So the other cool thing about how I design stuff is I design it in a fashion to where you don't have to weld the internals up. I get enough weld through the arm by placing the ribs in strategic places so that all of it can be welded externally so you can snap the arm together. Again, another very important factor as to why I was referring to the internal ribs have to have that as much weld as possible, not like little tiny slots. You want as much weld as possible so that I can put the arm together literally like this, turn and burn everything from the outside for the most part, other than there's some stuff inside here that these cover plates, you know, go on after per se, but most of this arm can be welded from the exterior and welded as is, just like this on the bench. Let it cool. And so while you're doing this, you'll tack a spreader into this side. Just take a piece of scrap material, tack that spreader in, it'll hold it. You let the arm cool. Then what we're going to do is break out the fixture. And then I'm going to take the spreader out of that side on the chassis. Then I'll set it in the fixture with the bearing cups. And I will turn and burn all the bearing cups. Now, mind you, 85% of the arm is already fucking fully welded and ready to shred. So what that means is most of the movement has already taken place. So it's very important for keeping and upholding the accuracy of these bits and making sure the arm doesn't cattywampus on you. You let it move a fuckload. Then you set all the pivots. And then we will weld up, you know, the bearing cups into the pivots like so before we cap them and then put the wraps on them. Now, obviously, like the rear wraps you can't really put in the fixture, so to speak. The front wrap on the cup you can. But, you know, we'll put the caps in and weld that stuff up after we weld up the internals in the fixture. Then we'll pull it from the fixture and do the final welding on the wraps on the table. So we'll get the final welding of him. So that you have 85-90% of the arm already moved and feet fuckeried, you know. Then you set the cups and stuff. And then you would go and do the final wraps. So this is one style, and one way I like to do it. Another way is like how I showed you with these T4 arms, where I'm just building all of it in a fixture, and you're being very cognizant of the arm, so to speak. So you're not putting crazy amounts of fucking heat in it all at once to make it want to dance too much. You're just kind of taking your time, and you'll probably go back and forth between, you know, driver and passenger side. And again, this is another common way. Like, obviously, these arms are built in that fashion too, where they're literally welded and built in the fixture, as opposed to what I was referring to, where you build a chunk of it out of the fixture, then fixture the pivots, and then you go from there. So those are two variations of doing that. The third variation, which is like what we do, so here's like that all-wheel drive arm. That, for the most part, it'll probably build this in the fixture, weld it all up, and then from there they will pull it and then, you know, final weld the bits out of the fixture that they can't reach that are in the fixture, so to speak. So they'll do as much as they can in the fixture. Here's another perfect example. It's all done in the fixture. From what I can gather, at least in this image, and from talking with them back when he did this, is fucking over 10 years ago. But and then a third style, a little bit more of the redneck style to some degree. Again, here's a Tisco arm being built in the fixture. Let's see here. Where's my plasma table friendly? So like this arm right here, you know, it's just snapped together. Then you just set the bearing cup. So there's no fixture for these plasma table friendly ones. They're kind of self-fixturing. So you'll snap it together. You'll weld it all up. Then you'll take your outer bearing cup. You'll tack it in place. Then the chassis pivots, you actually take the arm and set it in the bulkhead in the truck and tack the pivots real quick. Do not weld them. Just tack them so you don't burn the fuck out of your Delrin. Then you'll pull it out, tack a spreader into the chassis side, pull the Delrin sleeves out, then weld up the bushings on the chassis side, weld up the cup, weld up the overlays, and call it a day. So this is like the most redneck version of doing it, because there is no fixture used. You basically just have the spreader used for the chassis side, which is your actual bulkhead, and then you tack in a spreader to be safe. And then for the bearing cup at the upright side, you just let it ride. It just sits right into that pocket. You center it and call it a day. Now, for obvious reasons, that's the cheapest cost incursion, so to speak, of these arms being built, you know. Same with like these plasma table friendly arms. It's done in that fashion, the cheapest, simplest way. The more complex arms and more race-based stuff that we're doing, they're going to be done in fixtures. like so, and done in those processes to decrease any frustration or headaches, But there's a fuckload of guys that do that plasma table friendly-esque method, and they do just fine, no problem. If you take your time, etc., you definitely can have a very nice product that is totally straight and all dialed. The other trick too, to avoid a lot of warping, etc., is you always weld the external main stuff last. You do all the tab and slot stuff and the internal stuff first, and then do all the exterior last. So I'll weld up all the tab and slot stuff, on this arm, or even Ross King's arm, weld up all the tab and slot, let it cool, then come back, weld up the main external stuff. And I find that tends to have, same with these, weld up all the tab and slot stuff first, let it fully cool, then come back and weld up all the big main exterior lines. And I tend to find that has the least amount of fuckery from movement. Now, granted, before I did just draw shit all day long every day, I was a fabricator. I did a lot of arms welding, hours and fucking hours. So I've telling you this stuff from actual personal experience of fucking stuff up, or turning and burning, and then being like, oh fuck, arms just fucking bananaed, and you're just sitting there well, now the fuck what, and so sometimes you got to figure this shit out the hard way, so to speak. But yeah, and that's again just different ways of doing it, with or without a fixture, so to speak. From there. So yeah, so that's that process, those different processes. Oh, and the biggest, gnarliest thing is if you really baller, you're going to post machine everything. And what I'm referring to is let's focus on the bearing cup. So let's go back to what we showed before. And I would say the vast majority of guys do not post machine simply because of the cost. You know what I mean? It adds cost. I think Mike Robinson posted something about this not that long ago. He works at Mason, but he's also he's a pretty cool guy. But he is now doing all of Cho's uprights. I'm designing several tube chassis TTB luxury pre-runner applications right now for a few different clients that is using the Cho stuff. So if you're into fucking TTB beam type shit, it's fucking cool, man. I've been working with Cho and the guy that designed the stuff for Cho, Performance Metal Co. Another design guy like myself who does some rad work. His name is Brian, Performance Metal Co. Let's give him a shout out real quick. PMC. So he designed these beam stuffs, etc. for Cho, and again, he's just another guy that does CAD work. I think he might do some fabrication, but he's definitely doing a lot of CAD work as well. And so he designed the beams, etc. for Cho, and we have he's helped us get everything laid out, etc. to make sure all of Cho's beams are totally kosher. I don't see any of the beam files up here, but again, just another. Like I have said many times, there are a lot of guys in our industry that have a lot of talent. And he's done a lot of cool shit. So you could totally hit him up to do fabrication. I love the dimple die shit. Always been a fan of dimple dies ever since Kudella fucking had the light racing dimple dies first released many, many moons ago. Oh yeah, so here's some of the Cho beam stuff. So this is what I'm referring to, the TTB stuff. Yeah, we got several tube chassis stuff that I'm doing right now with those beams. But let's get back on track. We're focused on post machining arms. So what you would do, let me find the picture he posted. There we go. So where this starts off is your bearing cups are going to start different. you're going to specifically use bearing cups that are 30 thou under machine. Cartech does sell them. You could easily, like I said, you could easily draw and make your own too. So let me just pull these up so you can see what I'm referring to for the big trophy truck shit. The reason for that is weld fuckery. The other thing too, I forgot to mention it. Or no, we'll talk about now, welding slugs. So you have two variations of how we would do the bearings, so to speak. If you're not going to post-machine stuff, and I'll get to the post-machining here in a second, you have to run a welding slug, a brass slug in the arm. So here's like an 1.5 inch bearing cup brass slug. This fits all the normal, the HCOM 24T, TKH type stuff. FK, yeah. So this goes into these cups, and that is what is put into the arms when it's fixtured. So, like, that's what's bolted in here when it's fixtured. That's what's going to be bolted in here when it's fixtured. I mean, it's not in the CAD model. I don't need it in the model to accomplish the fixture, so to speak. But they bolt that in, and then that's how it holds the cup, not only centered because of the slug has this thread in there, but it also makes sure that your bearing doesn't warp this bad boy too much. Now, they technically will still warp some, but the only way to prevent the warpage of it is to do post-machining. But if you're not going to post-machine it, like, you have to run a brass slug in the arm. You can't not do that, or you shouldn't weld cups in the arms without a slug of some sort, because it's going to fucking, you're going to cattywampus that. Like, you'll oval the fuck out of that. I've seen them oval like 10, 15, 20 thousandths. Easy. Especially on some of the guys that are MIG welding long travel kit type arms, where they just fucking crank that welder up and turn and burn. And next thing you know, that fucking cup's like 20 thousandths out of fucking, cylindrical. So with that said, you can start with a bearing cup that is intentionally machined for that. And you'll see it right here. 30 thou under. Boom. The inside diameter of this cup is intentionally undersized, 30 thousandths, to prevent it from warping, distorting when you weld it. After you weld it, you'll need to hone the inside diameter to match your uniball. Hone post-machine. So, Mike Robb, this is a Mason lower arm. He is post-machining this cup to make it fucking bitchin'. So, for obvious reasons, all of this welding, and he is a damn good welder. You cannot fucking knock him for that. The dude can fucking turn and burn. So this is putting a fuckload of heat into the arm. It's going to move shit. I don't give a fuck how nice you machine the bearing cup initially. It's going to move that fucker. Like I'm saying, 5, 10, maybe 20 thou. It's going to move it a bunch. So they have it initially undersized 30 thou on that interior diameter, so they can just go in and open that fucker up. So no matter how out of round it is, they'll just machine it back out to being fucking a perfect cylinder to match the bearing fit. This is considered proper. I want to say ID Designs does the same thing, and that's also why they're so fucking expensive. Oh yeah, well, here's post machining of an upright face, but you get the idea. Is you're post machining it after all of the welding to make it fucking rad. The cost on this fucking sucks. There's no way around it. It adds a lot more cost to do this. I mean, if you think about it, you got to chuck it all up, get it all in place, etc., etc. Like, you got to do this. This is what you have to do after the arm is welded. So think of the cost incursion and time incursion. That's why the vast majority of guys are simply just slugging. They're running the slugs in them and calling it a day. But like I'm saying, if you're going to take this seriously, you need the slugs. For $66 from Cartech, like, that is a very cheap insurance for welding arms up. And yeah, so. And then, and this also applies to like the UTV type shit too. Like the guys that are running 7/8 bearing UTV stuff, like they slug them too. All of our clients do. They have them slugs for the interior, slugs for the exterior. It definitely helps big time on that stuff. space overlays between boxers without internal ribs. So on the UTV arms, like I showed you that Master Fab one, that one have internal ribs in it. Not all of the UTV arms we designed have internal ribs. That was a specific request from Brian at Master Fab. Most UTV arms are just straight hollow, and a lot of them are like 095 material. 7/8 bearing cups exterior, 5/8 rod ends interior, maybe 3/4. Most of them are 5/8 rod ends on the upper arm. But we're going to get to upper arm stuff next week. For lower arm on the UTV stuff, you have to remember most of the UTVs, the bullshit is mounted off the upper arm, the coilover and stuff like that. So we'll go to all sub. I already gave Master Fabrication a shout out. So these are two people we designed for that I'm allowed to disclose and not offend anybody. A lot of the stuff that I'm designing for when it comes to clients like Allsup, Master Fab, some of these other guys, etc., we're under NDA. You'd be surprised how many individuals there's individuals like myself. There's a handful of us in the industry that are designing for other guys, companies, race teams, shops, things like that. It's not uncommon that the owner of the shop, the company, etc., does not want guys like myself to disclose, post, or mention to others that we are doing their design work. And it's totally fine with me. Like, we have a standard issue NDA at Tech that my wife sends out with every client introduction and everything. If they exercise that NDA, we can't post anything on our Tech page. So if you see it on the Tech Instagram, that means that we have permission to showcase that specific item, Otherwise, like, we don't per se. So like these are the new Pro R kit we did for TAV fabrication. These arms are like pretty much all 095 with some internal ribbing, etc. These bearings are 3/4 inch on the internal, 7/8 on the external, and it's a Pro R. But the point being is, if it's under NDA, we can't post it on any of this, etc. And that's just, goes with the territory. But it's not uncommon. So a lot of the stuff you'll see, etc., the probability that it's not designed by the owner of that builder is, high, so to speak, these days. But let's see, why the fuck? Come on, Mitchell. Why aren't you posting more of your fucking arms, bro? There we go. So, like, here's some of the, standard issue type of UTV arms that we've done for Mitch. He does like the tubular lower arms. They are like, these are a little bit more of the high clearance based stuff. Again, very popular. We do run Delrin on the interior, 7/8 on the exterior. His uppers on the stock replacement stuff run Delrin, and then the bearing cups. And I don't want to disclose what we have done geometry manipulation wise, but we have manipulated the geometry of his arms to kind of cater to some positive aspects. And they are all 4130 TIG welded. I'm going to do more episodes on UTV stuff, because I definitely feel like there's a lot of cool stuff we can talk about with how the geometries are of these cars and things like that. But again, this is just one of the guys that we draw stuff for, and he's a fucking hard charger, man. Allsup does not fuck around. That is for sure. And so the UTV stuff, although dialed down from like truck stuff, is still pretty cool. We do a lot of UTV design. It's just, for obvious reasons, the things don't need to be as gnarly as the big truck stuff. These cars weigh fucking like 1,800 pounds, 2,000 pounds, and they're not seeing the same speed. So like the force applied to all the bullshit is a lot less than what we're seeing in the big truck stuff. So guys, yeah, we are a few hours in, so we're going to call it for tonight. So this will be episode volume 5. I really appreciate you guys checking this stuff out. I know there's a lot of people that probably think this is super boring. I actually really like this stuff, despite me being super fucking tired today. It's been a very long week. I don't really have anything that I feel like pedaling or pushing this evening. We'll get back to the grotesque product pedal pushing next episode or volume. But I appreciate it, guys. And as always, gentlemen, pitter patter.